specific brick. Similarly, the complete IT industry or the semiconductor industry is based on the transistors. So transistors do play a very important role. Now, I think so after the invention of your transistor, you had integrated circuits that came into being, and it was first translated into microprocessor by Gordon Moore. So I'm just going to be, can you see anything on the screen?
Yes, sir.
Yes, sir.
Right. Just can you see? Hello?
So we couldn't see anything.
So you stopped presenting.
Okay. So, can you see this?
Yes, fine. No, it's fine.
Yes, sir.
Yeah. So this is what I was mentioning since the very beginning. So one of the co-founders. So after this invention of your transistor, what came next was your integrated circuits, which was essentially made up of these active devices. By active devices, I mean the transistors, and the passive devices, what we mean is your capacitor and resistors, and then eventually for it can be generally bifurcated into digital and analog. So in analog, you would have all these things, while in digital, it would be predominantly your transistors, and then you came up with these ICs, all kind of combinational and sequential circuits. I would be just asking you the difference because I expect you to know that. So after this, ICs, I think then you finally came with the 4004 microprocessor way back in 1971, and one of its co-founder was Gordon Moore, and he came up with a paper, I think around the mid-60s, which is famously known as the Moore's Law, in which it clearly mentions that the number of transistors incorporated in a chip will approximately double every 4 months. So, are you able to see the screen? Hello?
Yes, sir.
Yeah. So this is where this is still being followed in the so-called semiconductor or the IT industry. And why this is very important is because in this course we are predominantly studying 8085 and 8086 microprocessor, and probably a little bit up the ladder. So basically the whole focus is on microprocessor. As I had mentioned before, there were different companies who had come out with microprocessors way back in the 1970s that include companies like Motorola, IBM, and so on. And it's almost like 4 to 5 decades now, and but then Intel followed a particular type of architecture. So the whole course on architecture would be there in your subsequent classes or maybe courses that you take in future. Maybe that you take in future. Intel is one of the dominant players in the microprocessor industry, and they are following a particular type of architecture which is generally called as the x86 architecture. So it all started with your 8085, then 8086, and the improved version of your x86 processor. The other, which you may have heard, is basically your RISC or ARM type of architecture. Though there are multiple types of architecture which people have researched and got into its existence, but these are the major players around the globe. So like Apple and all, they do not essentially at this moment of time follow the x86. They probably follow the RISC type or ARM type of architecture. So we will be mostly focused on the architecture that actually came out of Intel. So are you able to see the screen?
Yes, sir.
Yeah. So, by the way, I had actually asked you to kind of brush up your previous knowledge. So, before I get into the internal architecture of your 8085, I already talked about the timeline of your microprocessor starting from 4004. I would now ask you, or voluntarily, somebody who can tell the difference between a combinational circuit and a sequential circuit. So let's start with Virish Bharadwaj.
Hello, sir.
So what is the basic difference between your combinational and sequential circuits?
Sir, I believe the both of them requires combinational circuits generally require only one or two ICs, while one or two gates, when sequential circuits require more than two gates.
What are you talking? What's the difference? Difference between combinational and sequential circuits is in the number of gates. Who has taught you this?
Sorry, sir, I don't remember.
Yeah, Aman. Aman, where is Aman? Aman. I just saw Aman. Is he there in the class? Okay, next, Samatha.
Yes, sir. So
Yeah,
yes, sir.
yeah, go ahead.
In combinational circuit, output depends upon only on the current input, sir. In sequential circuit, whereas the output not only depends on the current input but also on the previous input, sir. So in sequential circuit, it depends on the previous input, so it requires feedback, sir, to store the previous input. In combinational circuit, there is no need of feedback based circuit, sir.
Yeah, very nice. I think this is at least this much you should be knowing to begin with. I mean, like you don't need to know in details about different types of combination or sequential circuit. But why I'm asking you is because we started to talk in terms of registers and counters, which is already existing in your microprocessor, and so your previous knowledge has a strong connectivity with the courses that would come that we are teaching that I'm teaching right now, as well as the courses that would be taught in near future if you continue to pursue in this VLSI and embedded system domain. So you have to have those knowledge, and then as you progress with time, you would be particularly focusing on, say, a multiplexer or a kind of a multiplier or a adder and stuff like that. So somebody tells me what exactly is, say, a register. Sudhir, Sai Sudhir. He's not there. Sai Sudhir. So this is why I kind of not encourage recording, but since I can actually see, I called up a couple of names, though they are present here, but they are probably not physically present to take this class. So recording doesn't help. So I would completely discourage recording. I want you to be present in the class, not to just log in and switch on and that's it. And then you're not actually present for the class. So I don't encourage recording at all whatsoever because of this very reason. I can see these people are logged in, but probably they're not either sending any message or answering me. I don't know why. So anybody else? Arvind, Kareer, can you answer what I asked you?
Yes, registers are like temporary storage memory locations in the CPU.
Okay, so that is
The
a
command
very
is
generic
there.
statement. Can you speak a little bit more specific of what, I mean, like how do you actually relate in terms of being a sequential circuit? How does it work? Or you can take one of the examples of the types of registers that you come across. Yes.
No, sir, I don't remember that.
Okay, so anybody else? Daksh?
Yes, sir.
Yeah. Can you elaborate on registers?
Sir, it's a quickly accessible location that is present to a computer's processor. So, for example, the next instruction that the processor fetches is stored in the register while the current instruction is being processed, so that the next instruction is immediately available after that.
Well, that you are talking, I'm talking in terms of your digital electronics. I think you are talking that you have faster accessibility. Why? Why do you think? What are the other types of memory elements?
Sir, RAM, ROM, and secondary primary storage and secondary storage, basically.
What is secondary storage?
So the storage where we usually keep our data files, like our hard disk and stuff like that. I mean, which can be accessed again. Like, and we can, sir, I don't know how to define it, but I have an intuition of the overall idea.
Yeah, so I think that is why I'm trying to build up, not, I'm taking the bottoms up approach. So initially in way back in the 70s, when these processors came into being and they were in the very nascent stage, you didn't have anything like operating system. Like what we will be just studying is 8085 in detail as well as 8086 in detail. And the family of x86 is actually a advanced version of 8086 type of microprocessor, and that is actually coming in the CIS, which is complex CIAC, I think CIS type of architecture. So so basically in that you are not talking in terms of operating system or compilers or any other types of external memory devices like your hard disk. You generally talk about RAM, and you talk about your ALU system, which constitutes of the microprocessor actually constitutes of your registers and your ALU and your control units. So I think now I will just give you the distribution of marks. Please note down, all of you. Your minor exam is going to be of 10 marks, as in like the overall weightage would be of 10%. Then your midterm would be around 15. And the assignments or your lab sessions would be having a weightage of 25. So depending upon the situation, either it will be completely based on your assignments or it will be completely based on your lab based on your different assignments which you may be required to do, as probably even in terms of projects. So assignments come lab come projects would be constituting of 25% weightage, and your final exams would have a weightage of 50. So all in all, the total is 100%. So the minor happens to be 10, midterm is 15, 25% weightage would be given to your lab or assignments, so or a combination of these, and your final exam would constitute 50%. Is that clear?
Yes, sir.
Yes, sir.
Okay. Now, before I start with my class, I think I also need to, or maybe I can give you this at the end of the class, at the end of the class. So that is references. So let me just go to the Just a moment. Are you able to see the screen?
No, sir.
Yeah, just a moment. Just a moment. Where are you? Yeah, can you see this?
No, sir.
No, sir.
So you stop presenting again.
Can you see?
No, sir.
Yes, sir.
Yes, sir.
Yeah,
Yes, sir.
yes. Yes, sir. No, it's visible.
Yeah. So in this, basically, we are talking in terms of the differences in different types of your processors. Say in your microcomputer, your microprocessor, and your microcontroller. Okay, so what exactly is a microcomputer? A computer with a microprocessor as its CPU, and it includes your memory devices like we have already talked. It can be your different types of RAM that includes SRAM or a DRAM, and your various types of input output devices, which includes your monitor, your printer, your keyboards, so on and so forth. Then the other part is, so this you should be probably knowing in a better sense. The microprocessor, which is essentially made up of three major components, that includes your ALU, your registers, and your control circuits. The third type, essentially, which I will not be covering, and I think I will just give you some idea, is on your microcontrollers. So that essentially constitutes of your microprocessor, your memory, and your input output devices in a single chip. One of the examples for your microcontroller is your 8051 microcontroller. And remember, we are focusing this course mostly on your microprocessor. Microcontroller probably is an offshoot of this course, and the things as in like the architecture as well as the assembly language which you use or which you will learn in this course, you can actually use in your microcontroller too in the near future. So like you can actually implement that either in C language or in your assembly language. So basically you can run different types of instruction which you as an end user needs to implement or instruct your processor to execute. So we have already talked about things like nibbles, words, bytes, etc. in our last class. Now, a microprocessor based system essentially has this type of block diagram. You can note it down. In this, you give input. Either the input can come from the memory like some kind of a RAM, or it can be keyed in by the end user. So within the microprocessor, which constitutes of control units, ALU and register, you can perform all kind of arithmetic and logical operations. So as somebody did mention, registers, you have the fastest access of the data into your ALU system, where the data is being processed. By process, it means it undergoes arithmetic or logical operations. Okay, so once, say, a simple addition is performed in your ALU system, then the result is again stored back to immediate registers, which is supposed to be very fast. So register happens to be a very important component within your microprocessor system. Then this is either sent to a external RAM or output devices like your printer or your screen and so on. So in this memory, we are actually talking about RAM. Can you see and hear me?
Yes, sir.
Okay. So you can, so this is how it actually happens. So the communication between these three major units inside your microprocessor happens by different types of buses. So you have three different types of buses. What do you mean by bus? Anybody?
Sir, a way to transfer memory or data from one point to another.
Okay, what is that way?
Sir, there are a certain number of lines, and at the end of the lines there are switches, which right now we use transistors.
What do you mean by line and switches?
What, sir?
What do you mean by lines and switches? What
Sir,
exactly is physically
lines
there?
as in conductors.
Conductors?
Sir, yes, sir. From the line, as much as I've studied, I can say that it is used to transfer information, and there are certain lines. जैसा कि हम किसी motherboard में देखते हैं ना, जो lines बनी हुई हैं, and those lines are used to transfer information from one place to another. Let's say from memory to the processor or back.
So this is within processor, right? So what is that we are talking about?
So no, let's say कि memory है हमारे पास, हम memory से processor के अंदर हमें कुछ लेके आना है information, या let's say USB से memory के अंदर डालना है, तो सर वो जो lines होती हैं, जो अगर USB के अंदर भी हम देखें तो उन्हें bus कहते हैं.
Again, you are just, this is where I really feel you're unnecessarily. I forget motherboard. Within, let's just talk about a single processor. You've got a single 8085 processor, 8086 or x86 processor. What do you mean by bus within that processor? Anybody?
So it's basically a type of communication system that transfers our data.
Bus is a group of wires.
One by one. Yeah. Definitely, this is very well understood that it is some kind, it is a communication system. What exactly is there physically?
It's a pathway for digital signal to travel.
Two components. What two components? I'm talking about what is physical. Okay, what do you mean by bus? Bus basically, it's a kind of a usage. So, what exactly is physically present? I mean, like, is there physically that is present in any of these kind of microprocessor when we talk in terms of bus? Within a microprocessor, no, don't complicate things. First, you understand the basics. So here it's talking, if you can see on the screen, it is talking about system bus. So system bus is some physical form in which you are having the data being communicated. What is that physical form through which this data is being communicated? It's very simple.
Sir, lines of conduct.
Wire, right? Good. It's just simple wires. So essentially, through these wires, you are having communication between your memories, which can be RAM and ROM, your input-output devices, and your microprocessor, which is again having these three as a major components, like ALU, your register array, and your control unit. And depending on the type of data that you transfer, you define them as address bus, data bus, and control bus. Okay, so there are three types of buses within this system bus. They are address bus, data bus, and control bus. So what is actually happening? So you please note down this. This is actually the memory map and address of the RAM in your 8085 microprocessor. Please note down this. So this is important to understand what is exactly happening. So within these RAMs, suppose in your RAM 1, you have particular data. So say having a particular address. So exchange first, as a microprocessor, you would like to identify on which particular address you have a data. You would like to either first identify that address, choose the data in that particular address, and probably transfer to your microprocessor. And after identifying, say, two different addresses, which probably you want to use for, say, addition or subtraction or any kind of logical operation or any other operation, you would first like to identify the address in this RAM and then transfer the data from this RAM into your microprocessor, say in any of the registers. Then in that registers, you would again send it to your ALU system, where all kind of arithmetic or logical operations would be executed. After the execution, the result would be fed back within the microprocessor into your register or directly into any types of output devices or any of these segmentation of your RAM. So suppose you have 10 datas in your RAM 1 having 10 different addresses, and you want to add all the datas in RAMs. I'm just supposing it. Here it's completely defining your memory map and differentiating between the segmentation of that map. So suppose you have 10 datas in RAM 1 and you want RAM 2 to store the addition of all those 10 data in different addresses. In RAM 3, you want to store the subtraction of the first 4 or last 4 data in the addresses that is within your RAM 1 module. Say in RAM 4, you want to do ORing of the data which is there in your RAM 1. So these addresses would be first identified. The data will be taken from this RAM 1 into your microprocessor, say a register, and there all kind of arithmetic and logical operations would be performed, and after the execution of the operation, the result may be stored depending on the instructor either in your register or in any of these memory elements or your output devices. Is that clear? So this is the internal memory map within your 8085 microprocessor. You please note down this. Hello? Are you there?
Yes, sir.
Yes, sir.
Yes, sir.
Yeah, so please note down this. First of all, you should just note down this. This is very, very important. So it defines your address range starting from 0000 to FFFF. So the first one is from 0000 to 3FFF. That is the erasable programmable ROM. While the rest, RAM 1, RAM 2, RAM 3, RAM 4 are essentially your random access memory. So why is it segmented? Because you would want that your data should be stored, your raw data should be stored in particular RAM, your instructions should be stored in a particular RAM, and the results of your data should be stored in your particular RAMs. And to have different controls within your RAM, within your different types of RAM, the control unit of your microprocessor. So all these would have their data inside your EPROM. Even your instructions that you are giving your microprocessor may be stored in any of these RAMs. which may be with the data or which may not be with the data. So have you noted it down?
Yes, sir.
Yeah, can we go to the next slide?
Yes.
So in this microprocessor model, it essentially constitutes of 3 cycles of instruction. So what are these? So it is fetching, decoding, and executing. So basically, what does the microprocessor do? It fetches the data from a particular memory address or the data that an end user is fetching into your microprocessor. It then decodes that data and according to the instruction that is given by end user or the one which is already predefined by the set of instruction that is stored within your RAM, it decodes it and finally executes it within the microprocessor. So this sequence is continued until all the instructions are performed. So what is your microprocessor essentially doing? It is sequentially executing your instruction, which is either stored in your external memory or being newly defined by the end user. Are you there?
Yes, sir.
Any questions? Yeah? So we have already talked that the first microprocessor that came into being was 4004 microprocessor. And essentially it was a 4-bit microprocessor. We've already given the basic definition of a nibble, of a word, of a half word, so on and so forth. So now we are going to be focusing on, or all the talk that I'm giving is focused on your 8085 microprocessor. So 8085 microprocessor essentially is a 8-bit microprocessor. So this 8-bit can have at most 2 to the power 8 kind of different combinations. So I think you should we are now getting onto the 8085 microprocessor. It's a 8-bit microprocessor which can have a total bit pattern in form of instruction sets totaling to 246, representing only 74 instructions per se. So please note down all these important parameters of your 8085 microprocessor. Are you there? Class?
Yes, sir.
Yes, sir.
Yeah,
Yes, sir.
Please note down. So a lot of, as I was telling you before, a lot of times we are actually doing the code either in the binary form or its equivalent hexadecimal form. So when you're writing the code for your microprocessor to execute, the machine only understands zeros and one. I asked you, why zeros and ones? Anybody? Why zeros and ones? Deepak?
So because switch on and off. Just
Yeah, what is on and off? Ram, what do you mean?
So the hardware process.
low voltage means
Hardware. What is 0 and 1 when we talk of any digital device which would be used across the board, from servers to your 5G or 4G technology, on communication device, on routers, on servers, on any kind of digital device, or even in your DSPs. That's ultimately they are trying to focus on processor. Even if you take DSP courses, the focus would be always going towards making a processor. Yeah, Anil, I can't hear you.
I think it's.
Am I audible?
I have to. It makes switching
Sai,
off and switching on, sir.
It's maybe high voltage and low voltage. In what? This value is referred. That is, so is there a range, and with respect to what that we are talking? Are we talking in terms of combination circuits or gates or what? And gates are made up of? So are we talking in terms of gates or transistors? General transistors. What do you mean by general transistors? So everything is different. So when we are talking about digital electronics, we are talking about operation of transistor in either the off state or in the on state. So off state would have a particular limit or particular range. Similarly, on would have its own particular range. So for digital application, since this whole course, your digital electronics as well as your microprocessor is predominantly a digital or analog. Yeah. So we are only talking about on state and off state. For analog, it is different. For analog, the transition, the transistor that we talk about is in a different stage. Here we talk of transistor operation only in the off state and the on state. So everything boils down to transistor. That is why we are just defining in terms of zeros and ones, period, which has its own particular range. What is the VDD? Yeah, can I ask somebody else? Yeah, Daksh, Deepak, sorry, Deepak.
Yes, sir.
What is the range? I think this you people also must have done before. What is the range that we are talking about? In digital electronics, we must have taken this course before, in which there must be IL, HL, there must be a noise margin. Have you heard these terminologies before, or you've never done these things?
No, sir, we've never done.
I think we've.
No, sir, we haven't.
We have done, sir, but we do not remember the ranges clearly.
Somebody taking the.
So you need to brush up first.
So we didn't do the noise part.
What is noise part? Noise part. So yeah, tell me. I would just want you not to give some sweeping statements or a very generalized statements. This course is based, and the references or the previous knowledge would be focused on particular expansion of your previous knowledge base. Yeah, Manas.
Says the 0 to 1.5 volts corresponds to corresponds to 0 bit, low voltage into 0 bit, and means it is 0 bit, and 3.5 to 5 volt corresponds to 1 high voltage.
Yeah, so this was happening in. Okay, so this is basically the range probably which you have studied, and that would be true for your previous, I mean, like your technology node, which was long time back. So now your maximum VDD is coming in the range of 1.5 only. I mean, like the latest microprocessors, or even 2.5. So it is no longer 5 volts or 10 volts or 15 volts and so on. So yeah, I think this is what I'm saying. At least you should be knowing noise margin, you should be knowing what is zeros and ones. So this is the zeros and ones for your particular transistor, and that defines if your transistor. So when you say 0, ideally your machine have these gates made up of these transistors which are in the low state. So the transistor is in the low state. So that is what is meant by 0. And if your transistor is in the high state, that is what is meant by 1. Yeah, definitely the range as well as the upper end would be defined in terms of your technology node. So if you are having a transistor of say 70s or 80s, the peak of the VDD or the peak of the voltage would be much higher than the transistors that have come out in the last decade or so. So coming back to these slides, why are we talking of this is essentially that when you're giving these instructions, the data as well as these instructions are always understood by your machine only in terms of zeros and ones. What does that mean? The machine only understands whether the transistor is in the high state or is in the low state. Okay, so equivalence of this 8-bit you can write in the form of hex. What is hex? Hexadecimal form. Okay, so like in this slide that we are talking about, if you see at the bottom end, there is a 8-bit number which is 00111100. So what is its equivalent hexadecimal form? Please, all of you. What is its hexadecimal form?
सर ब्लैक स्क्रीन आ रही है अभी.
हाँ?
क्वेश्चन
Yes,
क्या है?
sir.
ब्लैक स्क्रीन आ रही है.
That doesn't matter. You try to calculate. I've given you.
सर क्वेश्चन नहीं याद ना. 0011
00111100. This is the 8-bit number. Try to convert into hexa form. Just convert it into hex. Give me the equivalence.
C.
3C.
Exactly. So for any type of instruction or any type of data, it is also written in its equivalent hexa form. When you go down to the lowest level language, so either you can write in the binary form or its equivalent hexa form. So all types of different instructions can also be written in its equivalent binary form or its equivalent hexa form. So we will be talking about the equivalence of various instructions in hexa and its equivalent binary form at a later stage. And all these different companies have defined a particular 8-bit for a particular instruction, like add, like subtract. So this we will be taking at a later stage. So that was the idea of taking you back to defining. So when you are talking in this term, you are actually introducing the assembly language, which is the lowest level language, which the machine readily understands, because machine only understands zeros and ones which are there in your digital blocks made up of gates which are made up of transistors. So ultimately the status of those transistors are either in low state representing zeros or in the high state representing 1. So this is the connection. So each company means Intel would be doing its own. Initially Intel did its own, IBM did its own, Motorola did its own. But as time progressed, there is a standard. Since we are talking about microprocessor which came way back in late 1970s, I think 76 was 8085 and 78 was 8086 and 71 was when it all started, which is 4004. And in between also there were other types of microprocessor. But why we need to concentrate is 8085. It was a big thing at that moment of time, and 8086 is the type of architecture whose improved version we are still working on, as in Intel is working on, and most of your laptop and desktop are in the same are coming from the same extended family or improved version of your x86 microprocessor architecture. Remember, we are not talking about the other types of architecture, including your ARM or RISC architecture. This course is predominantly on your x86 microprocessor. So basically, that has come out from Intel. So as time progresses, the engineers need to work upon not only at the transistor level, not only at the circuit level, they also need to improve upon the architecture level of these processes. So to work upon all these things, you need to know assembly language. So even if you are using microcontrollers, which are basically used for various specific applications, like a microcontroller can be used in traffic signals, it can be used in your lifts. So there you do not need such powerful microprocessor. Powerful means such a high-end microprocessor. You can do with a very low-end microprocessor because the processing unit doesn't require that powerful processor. So generally when you are giving instruction to your microcontroller or some kind of embedded device, embedded system, you can work having knowledge of assembly language or its equivalent C language, so that is compatible. So this assembly language is the program which give instructions to your microprocessor to execute sequentially. So each company ranging from Intel to IBM and Motorola defines. I can hear some disturbance or a noise. Any questions? Can you see this screen or not?
Yes.
So each company has symbolic code for its instruction. That is what I said, that each may have its own different symbolic code for various instructions. So it is quite possible, at least at the initial stage, that the symbolic code or in binary form for two different chips may be different. Symbolic code for instruction basically means, suppose the instruction is simple addition. So let me just talk in terms of its hexadecimal form. So a binary, 8-bit binary, say 3C. may be for adding produced by a particular company, say IBM. So Intel may be having, say, 3D. So one is 3C, the other one is 3D for the same operation, like addition of two numbers or simple addition. So these are also called as your mnemonics.
So could you pronounce that again?
It's already in the screen.
No. I mean, I don't get the pronunciation. Can you pronounce that again?
Mnemonics.
All right.
So using the same example, like for your 3C, you have what you call as the opcode or operational code and the operand. Just hold on, just a minute. So the 8-bit binary number 0011, you know, it's not sure. 1100 translates into 3C. Okay. So there's another example, like I said, 100000. So in hexadecimal, this is 80, and this would probably represent, say, add B. What is add B? Add B would be adding to the contents of your B register in your accumulator. So the contents within your register B, so we have already defined it. This is actually going into a particular microprocessor form. I will just give you, yeah. So when you're talking about 8085 microprocessor, you can see accumulator. So this is basically a programming model. You can see accumulator, which is 8B. You have flags, which is again of 8 bits, accumulator of 8 bits. Then you have B, C, D, E, H, and L. These all are registers, again of 8 bits. So we will be talking in detail about these at a later stage, but just since this thing came up, I just wanted to inform you how your assembly language is related to the execution of instruction, which can be defined either in form of hexadecimal form or its equivalent 8-bit number. And each company may have its own independent form. Any questions? Are you there?
No, sir, none.
Yes.
Yeah. So coming to the features of 8085 microprocessor architecture, please note down this. It's a 8-bit general purpose microprocessor, which is capable of addressing 64K memory. It has 40 pins, requiring 5-volt power supply. Can operate with a clock frequency of 3 megahertz and is upward compatible. Yeah, so Ishan, what do you mean by upward compatibility?
Sir, I'm not sure.
So most of the times when you are making a progress in terms of the microprocessor or the operating system or the RAMs, it should be compatible with your previous generation. So what happens is, suppose you bought a desktop, say 5 years back or 10 years back, it should be compatible with the new scheme of things. That means that if you want to change a microprocessor in your motherboard with the improved version, so the whole unit should be able to perform and should not have any issues when you are updating your processor or your RAMs and so on and so forth. So that can only happen if it is compatible. So that would relate to its type of architecture and other compatibility features. Okay, I think this would be the next slide and the last slide for today. So please note down, this is how you actually visualize a 8085 microprocessor. As mentioned, it has 40 pins. So within this microprocessor is what you, so Jen, have you seen any kind of a chip class? Have you come across any type of chip?
Yes,
Hello?
sir.
So what do you actually see in that chip?
Certain input-output pins and the processor.
No, processor, no. Any chip may not be having a processor.
So there's some input-output pins and certain circuitry which is usually
Yeah, that depends on what type of chip you're using. You may have, say, 10, say 500, or even you can have an analog 741, or so it is not necessary that it has a microprocessor. In fact, it doesn't really mean anything. It may not have anything.
Circuitry. It's not, I mean, not a microprocessor, but a circuitry inside of it. That may or may be.
Yeah. Only microcontroller would be having a processor. So it is having everything inside. It is having the processor plus your input and output devices plus your RAM. So only a microcontroller. But that microcontroller, like 8051, it will not only have that processor, but will also have these peripherals. including your RAMs and your input-output devices. And moreover, the processor that is used in your microcontroller, that would not be a high-end microprocessor. So whenever I'm referring to high-end microprocessor, we are talking of it having better efficiency, latency, and all type of different important parameters when we are talking of a processor. Computing power, so on and so forth. So please note down this. This is very important because this would be the baseline for, yeah, I think not this one, sorry, this one, yeah. Please note down this. So we will be talking in detail about all these different types of pins, its meaning in our next class. And before I end, I will also share you the list of books that is required. I think I will just send it to you, or probably share it to you, share it with you right now. Once you finish. Please note down, this is very important. So how many of you are having some kind of a notebook right now? You just listen to the class, or you note down also?
So no,
So we are noting down.
notebook.
I have notebook, sir.
Yeah. So please, this is very important. That's why I'm asking you again and again. This is like the starting point of your 8085 microprocessor. So it has 40 pins, and only if you see it physically, there is a dip to identify which side of your processor you need to count one. So there is a kind of a dip or a bubble in one of the corners of this rectangular shaped microprocessor, if you physically see. So it is only at one of the sides, and that helps you to identify which is pin number 1. So if you've already seen a processor or any kind of digital chip, remember there would be analog chip, and you may not be able to identify. When you actually physically see it, what do you see in a chip? Anybody? What do you see in a chip physically? I mean, like, you must have seen many chips till date.
So I think it's just integrated parts, integrated components.
No, physically,
like the ones that are soldered in.
With your naked eyes, what do you see? You are
some pins and some
Different
covering
pins.
with black.
Yeah. Yeah. So it is a kind of a black thing, and then there are pins coming out. So what I'm trying to say, how do you identify which is pin number 1? So generally, when you see, it's just some kind of black black box. It's generally black in color, and there are number of pins that are coming out each side depending on what type of packaging technology they use. So when I say packaging technology, it's the IC packaging technology. Okay, so here you will see this is very much rectangular in form, and the pins are only coming sideways, one side and the other side. So how to identify which pin which pin is like your starting pin, which is like pin number 1. Otherwise, you can.
Sir, on its surface, we have a small semicircular.
Yeah, that is what I just said. That it has something like a dip, or either it's protruded or there is a dip, and from there you can actually identify, okay, which is pin number 1 and which is pin number 21. So that is what I was trying to make a point. So I think if you have a real lab session, you may have to identify. Otherwise, you would generally you try to plug it in a breadboard or something like that. So that is why you need to identify which is pin number 1, and that is defined by actually observing that dip or that bubble, or sometimes it's also protruding in nature. So it's either a dip or a bubble. So yes. So it has all these different types of inputs like your SID or different types of addresses. So I think the 0 to 87 is like kind of pins which are used both for address and data purpose. Okay, and you have A9 to A15, which is essentially used for your addresses. So remember, this 8085 has 16-bit address. Please note down, this is very important. It has 16-bit address and 8-bit data. So in your external RAM, you have data stored in a particular address. The address of that data is defined by a 16-bit number, while the data itself is 8-bit. Is that clear? So the address is 16-bit. So suppose there are 10 buildings, and each buildings have 10 houses on each floor. Each building may be having, say, a maximum of 10 floors or 5 floors, so on and so forth. So how do you define a particular address? So similarly, in these memory devices, you need to define a particular address. So how do you reach to a particular address? That address, when you are posting something, say a mail to them, you would be defining by writing the complete address along with the pin code. Similarly here, the data where you want to probably post, say, addition of 2 numbers would be defined by these 16-bit address. So data would be only of 8 bits and the maximum capacity of 8 bits, which you can translate into a hexadecimal form. Okay, questions?
Sir, will we cover circuitry inside it also?
I didn't catch you. What?
Means how it is going on, the circuit inside the chip. Are we going to cover that that part also?
Your voice is not clear. I cannot catch your question. Ramohan, go ahead. I
He's
mean,
asking if we'll cover the circuits and stuff for this.
internal architecture will be there. Yes, internal architecture will be given. Internal architecture will be definitely there. Any other question? So generally it will be, different modules which are defined in this 8085 microprocessor. That would be very much there. That's a part and parcel of your coursework. But if you start talking of how to actually design a simple register, that you need to learn. I mean, like that would be a part of your, say, a digital IC design course, which I think probably you have not done. If you're using some kind of a analog circuit, you first need to design a simple differential amplifier or even a very simple single stage amplifiers and stuff like that. So that itself needs a different type of so I do not think you have come to that stage, whether in digital electronics or anything. This is just one of the courses in the overall scheme of things. So analog electronics, basically you need to do it again using the transistor in the saturation mode or your linear mode. I mean, like different books define it differently, but that is not the same as transistor being used for digital application. So from there you move forward and try to get all the various parameters for your analog circuits. So remember, everything that you're doing in the industry, it is mostly silicon based and mostly offshoot of your MOSFET technology. So MOSFET technology is your transistor technology. So the moment you go into digital domain, it is offshoot of your CMOS technology. So the base is your MOSFET transistor technology. So CMOS is what? CMOS is just an inverter. CMOS is complementary metal oxide semiconductor, which is a simple inverter. In analog, you don't need to use a CMOS technology. You only use a MOSFET technology. So you can do, you may have a CMOS configuration, but it all depends on what type of, analog requirements are there. So that itself is a huge course. I mean, based on your MOSFET technology, how do you get improved versions of different parameters that are required in your circuitry? So like, yeah, I think I would not go beyond this. So there are various specialized courses on embedded system, on this microcontroller, on your analog IC design, on your digital IC design, on your microprocessor architecture. So sometimes it is also called as VLSI architecture, or computer architecture. It's more or less the same or have a huge overlapping. Any other questions? Class?
No,
Say
sir,
something.
none.
Yeah, so I think first try to brush up your previous knowledge, including whatever you have done in your digital electronics class, and let's introduce with the microprocessor per se. In this whole course, you need to learn about internal architecture, its programming model, and then the assembly language, how to actually execute different types of instructions, and how do you make your microprocessor run. So this course is not basically on your digital IC circuits. That's something different. So that you have to actually start making either one of those combinational circuits or sequential circuits and so on and so forth. At the end of the day, the role of engineer is to improve in terms of the transistor, improve in terms of digital design, improve in terms of analog design, improve in terms of its architecture, and improve in terms of so many other things. And continuously, they are tremendous job in the IC design market, and it's exponentially growing. Application is going up the ladder, and requirement for chips across the globe, it's exponentially rising. So as long as you're buying, say, a Samsung phone, or using a laptop or a desktop or a server, or you're using, the next generation 5G technology, or even present 4G technology, or you're talking about IoT devices in the near future, smartphones, smart homes, smart cities. All these things will require smart sensors, smart processors, better memories. All these things are actually made up of these basic digital devices. Of course, you also have analog devices, and even your passive devices are made up of silicon most of the times, except for niche application like space application. The space market is very limited, but even for space application, you see most of the chips are coming out of SCL Chandigarh, which are Semiconductor Complex Limited Chandigarh, and they are mostly working on silicon based devices. Space application, why you need different chips, or for defense application, why you need different chips, is because their frequency of operation is different. Or in space application, you need different chip is basically because different temperature, it cannot operate in the nominal temperature, which is like most part of the earth is ranging from, say, -50 degree to +50 degree. Space application needs your chip to operate at higher temperatures. And defense, it's not the normal frequency you would want to operate your electronic devices on. So that would be a particular niche where only defense people are allowed to work upon. So that the commercial is very different from defense. So they have that cannot be interfered or something like that. Okay, is that fine? I should stop. Is there anything that I need to talk more? Any questions? If not, thank you. Let's meet next Tuesday. I don't get any response. Are you there?
Yes, sir.
Yes, sir. Yes.
Yes, sir.
Yeah, so as far as references are given, I will just post the references, or maybe give you in the next class. I've already given you the distribution of marks. I shall also give you the marks distribution, the books and references for this course. Thank you.